Well, hello there. Here we are again, and it is December 6th, 2020, and another exciting day in 2020. Today, we're going to learn about one of my favorite topics, which is called compound interest. And we're going to talk about how do we calculate that and why we should understand it. So let's get started. I would like to share my screen, so I'm going to do that right now. So hopefully you can see my worksheet here, and I would like to just show you a quote. And let's see if I can find the quote. There we go. This is something said by Albert Einstein, or at least it's attributed to him. Compound interest is the eighth wonder of the world. He who understands it earns it. He who doesn't pays it. So today we're going to learn a little bit about why he said that. So here's an example. We have Thomas, who invested in a bank account with a 5% return compounded annually. And it asks us to figure out which one of these formulas represents that. So we have some knowns here, and we start out with $3,000, and we're going to do this for 16 years. So this is what we're going to start out with here. We're going to have that. We know that for the very first year, we're going to make 5%. So I am going to just remind you from our last lesson that what we're doing is taking the original amount and then adding 5%. The way we calculate 5% is we take 3,000, we multiply it by 0.05, and in this case, that's going to give us $150. So at the end of 1 year, we're going to have $3,000 plus $150 for a total of $3,150. And you say, well, that's not that exciting. And actually 5% return is good on a bank account right now. Probably it's more like 1%. So let's just talk about if we leave it in there for 16 years, then how much money would we make? Well, I want to talk about a couple of things here. One of them is I don't want to have to do this little step 16 times. So, am I recording? I don't remember if I started the recorder. Yeah, that's better anyway. All right, well, anyway, that's me. And let's get back to our problem here. So I don't want to have to do this 16 times. So what I'm going to do is to show you a little shortcut method, which is what we're doing here is taking 3,000 plus 3,000 times 0.05. All right, what if this is the representation of what we're doing each year. So remember what we're doing is this is going to become the new number. This is what's going to get compounded. We do that 16 times. Pretty tedious, but if we use this little shortcut method, we're going to save time. So let's look at this. This is our expression. What if we factor out 3,000? What we're going to end up with is 1 plus 0.05. And I can rewrite that as 3,000 times 1.05. Okay, and if I take 3,000 times 1.05, I can see that that's going to be 3,150. And that is the same as what we got here. Here it took 3 steps. Here it takes 1 step. I like this much better. Now, here's where it really becomes powerful. What we realize is that if we take our expression here and we multiply by 1.05, that's going to get us this number. So instead of stopping and writing that down, we could just say, well, let's do it again, 1.05. And this we could keep doing. And we could do that 16 times. So if we have 2 times 2 times 2, we know that that's 2 to the 3rd power. We can do the same thing here. So what we're doing is taking 3,000, multiplying it by 1.05, and we're raising that to the 16th power. So that is our expression, and that's the same as that. They didn't plug in the 16, but we plugged it in because we want to know how much he's going to have after 16 years. So let's go back to the text box, and now we're going to say, all right, 3,000 after 16 years is going to be 3,000 times 1.05 raised to the 16th power equals. So he's going to have $6,548. So being that he started out with $3,000, he's over doubled his money here. All right, what we are going to do now is to open this file up again. just so we can have some workspace here. So we identified that this was the formula that we were going to use. Now, this is where I would like for you guys to just think about how investing works. Now, when I was around age 20 or 30 or somewhere in there, I heard about a mutual fund called Fidelity Magellan. Fidelity Magellan has been one of the best performing mutual funds over the last 40 years. So I'm going to just give you this stock recommendation that if you buy Fidelity Magellan today, you are likely to be a millionaire by the time you retire. So let's just take a look at why I say that. In fact, I recommended this mutual fund to my friend Gary, and he has vouched for this working. So let us just see what happens here if we had taken this $3,000 and invested it in Fidelity Magellan. So again, the mutual fund that I am recommending is Fidelity Magellan. And the average annualized interest rate over the last 40 years has been 15%. So let's just say that now I'm not sure how old you guys are. Let's just say that we're going to take an average age of, let's say, 20. So that means that we're going to be investing for 45 years. If you plan to retire, or let's just say we're going to call 65 the retirement age. So in this case, T will be equal to 45. Instead of the 5%, what we're going to say is our rate is 15%. So if we invest $3,000, now we're going to have the formula and we're using 15%, so this is going to be 1.15, and we're going to do it for 45 years. So what we're doing is taking 3,000 times 15% annualized over a total of 45 years. So what is that going to give us? 3,000 times 1.15 for 45 years. That is going to give us $1,616,370,000. So what I want to stress is start investing now. You don't even have to put anything else in. You just start just put $3,000 into Fidelity Magellan. So what I'm recommending is that you take, and I don't know how much you have, obviously you can do different amounts, but if you take $3,000 and you put it in Fidelity Magellan, and it keeps doing what it's done for the last 40 years, you will be a millionaire at age 65. Now, of course, there's lots of factors to consider. We have the inflation rate of maybe 5%. We have a bunch of other things to deal with here, but the point is, if you have the money working for you, you can have it compounded. We're starting with $3,000 and we're ending with $1.6 million. We're having the money work for us. This is a lot better than if we have $3,000 on our credit card and we're paying 18% interest rate, and we do that for 45 years. Now, this is where we were saying that compound interest is the eighth under. He who understands it earns it. He who doesn't pays it. So here we have $1.6 million. Here, you're earning it. If you use a credit card and you take that same $3,000 and leave it on a credit card and pay 18% over the next 45 years, what happens then? So again, we're going to take our $3,000 and we're going to multiply it. Well, we can just do the multiplication. We've already got all the numbers. So we're going to take $3,000 times 1.18, y to the x, 45 equals and it's going to equal 5.2 million. All right, so the question is, would you rather earn $1.6 million or would you rather pay $5.2 million? I say, since you now understand compound interest, do like Einstein said, earn it, don't pay it. All right, I went to engineering school and one of my favorite classes was engineering economics. And we learned to do all sorts of things with compound interest and future value of money, etc. And I really got excited about it. And I hope some of you do too. So I hope you've enjoyed today's lecture. I hope you have a great day. And I want to remind you to live with passion. Talk to you later.